We're finding horizontal asymptotes now. And you're like, what? I barely got the hang of finding vertical asymptotes. I don't know how to do horizontal. Horizontal asymptotes are way easier than vertical asymptotes. The idea behind a horizontal asymptote is simply what's going on when a function gets really, really big, when our x value gets really big. In fact, in pre-calculus and calculus, we call them end behavior asymptotes. So we're talking at the end of the function, what happens to this function? And so we're looking like right here and right here. As the function gets huge, what's going on? Well, it looks like, to me, as this function, as the x gets really big, y is getting really close to 0. And as the x value gets really big here negatively, it's also getting really close to 0. So my horizontal asymptote is at y equals 0. It's just an invisible line again there that as x gets really big, it approaches that line. Now sometimes they're not going to be at 0. For example, you might have a function that goes like this. And it seems to approach this invisible line up here, right? And then sometimes, and we're not going to work with these in Algebra 2, but you'll see them in pre-calc, sometimes we have ones that actually approach an invisible line like this. That's called a slant asymptote. And so it actually doesn't seem to approach a horizontal line at all. And like I said, we're not going to deal with those in Algebra 2, but just know that sometimes we don't actually have a horizontal asymptote. Sometimes the function looks like this, and as x gets really big, y also just gets really big. So how do we find them? Well, we have 3 rules for finding horizontal asymptotes. We look at the degree of the top and the degree of the bottom. Remember, the degree of something is just the power on the highest function. So you can't see that, but that says x cubed. So we look at the degree right here. Okay, we look at the degree on the top and the degree on the bottom. So in the case that the degree on top is greater than the degree on bottom, see, a 3 is bigger than a 2. So top degree is greater than bottom degree. There's going to be no horizontal asymptote at all. That's what that case where I told you there's a slant asymptote. You don't have to find them, but just know that there's not a horizontal asymptote at all. If we have something where the top degree is less than the bottom degree, then we have a horizontal asymptote, and it is always at y equals 0. Always. Okay? And the reason for that is a big mathy reason. It's because the bottom is growing so much faster than the top. So we end up with this small number divided by a big number. But you don't have to quite understand that. But what you do have to understand is that if the top degree is smaller than the bottom degree, we're going to have a horizontal asymptote at y equals 0. And finally, if the top degree is equal to the bottom degree, say we have something like this, what's happening is they're growing at the same speed, so the top is growing at the same speed as the bottom as we put huge numbers in there. And so we end up with a horizontal asymptote at a specific number. And to find that number, we look at the leading coefficient of the top and the leading coefficient of the bottom. So in this case, the leading coefficient of the top is 2, and the leading coefficient of the bottom is 1. So we would have a horizontal asymptote at the leading coefficient of the top over the leading coefficient of the bottom. So in this case, the horizontal asymptote would be at 2. But if this leading coefficient was anything else, then we would just put the leading coefficient of the top over the leading coefficient of the bottom. And that's it. That's all you have to do to find horizontal